How can I determine unknown measures of interior and exterior angles of triangles? This is very closely related to parallel lines crossed by transversals. All right. So, the interior angles is something you may have heard before, where basically I have angle 1, 2, and 3, and if I add all of them up, it equals 180 degrees. How do you know this is true? Well, I think the easiest way is to actually have a triangle. You tear off the corners and you put them all together and you'll still equal 180. But knowing about parallel lines crossed by transversals allows us to do like an added proof here. Basically, if I draw a line that's going to be parallel to the base of this triangle right here, right? So now I have these two parallel lines. Well, we know that alternate interior angles are congruent. So here's my transversal. Here's angle 3. This is the alternate interior, so this is also equal to the measure of angle 3. Because there's my transversal. Now if I look at this as a transversal, alternate interior angles, so angle 2, and this angle up here is angle 2. Which I have this parallel line, so this is a straight angle, so 2 plus 1 plus 3 would equal 180 degrees, or a straight angle. So in the measure of angle 1, angle 2, and angle 3, or the interior angles of a triangle, will always equal 180 degrees. It won't be more, it won't be less, it'll always be exactly 180. We can use that to figure out missing angles. In this example, we don't know what angle A is, but I do 36 plus 57 plus A equals 180. So what I actually do is just like to kind of do minus 36 and minus 57 from both sides. I do 180. I would just put this in a calculator, hit minus 37 equals, then hit minus 57, and you get 87 is what A equals. And if you added all three of these together, it'd be 180 degrees. So you can just take 180, subtract the two angles you do know, and find the missing angle. Now, exterior angles are if I have this triangle, here's my inside, right? Coloring that in. Outside, when you have one of the sides of the triangle is extended, you have an adjacent angle here that's created. That's the exterior angle. So so it can be any one of the sides. Now we're only going to look at one at a time when we're solving this in terms of how to determine what's the measure of this angle is, but also these two too would also be 2. All right. So that's the exterior angle. So we have our exterior angle here. We're just looking at one right now. We've extended this side. We're going to call it angle D. Now, what we know about exterior angles is that they are always equal to the sum of the remote interior. So if angle D is outside this part of the triangle, you have the angle C is adjacent, and then there's two other angles in the triangle. Those are called the remote interior angles, the ones that are far away from your exterior angle. And if you add them together, you get the measure of the exterior angle. How do I know this? How does this work? Well, there's a couple different ways you can think about it. You could think about it like C and D added together form a straight angle, or 180 degrees. And we also know that C plus A plus B equals 180 degrees because those are the interior angles of the triangle. Meaning that if C plus A plus B equals 180 and C plus D equals 180, A and B must equal D. Also, you can draw a parallel line here. So this line is parallel to this one, right? And we have these parallel lines. Now I have angle C, alternate interior up here, right? And angle B is alternate interior up here. And then B plus A plus C is a straight angle, which equals 180, which means that if I take away C, I would end up with D. You can also say here, you can say angle D. This is the third way to think about it. Angle D right here, and you have this transversal. You can see B and A are right here. B plus A. This is the alternate interior angle to angle D. So B plus A equals D. And that's what we're saying. Measure of angle A plus the measure of angle B equals D. The remote interior angles added together is equal to the measure of the exterior angle. How can I use this to figure this out? So here we have an exterior angle A, and we have two remote interior angles of 65 degrees and 48 degrees. You add 65 and 48, you get 113. That equals the measure of angle A. Pretty straightforward. One step. You can put this in a calculator, figure out the measure of the exterior angle. This is where it gets tricky. I have this triangle here with two angle measures. And I want to figure out what, say, y and x are. Well, these aren't just y and x. It's 3y and 4x plus 20. I can use my rules to kind of figure this out, everything I've learned about these patterns and relationships. 3y is an alternate interior angle to this angle here. So this is also equal to 3y. Now, I know that 45, 75, and 3y equals 180. So I can say that 3y equals 180 minus 45 minus 75. I could subtract these two numbers and then I would divide it by 3 using algebraic steps here to figure out what y equals. You could then note simply that 3y plus 4x plus 20 equals 180, right? So once I figure out y, I can use that to then figure out x. You could also say that I have 75 and 45 here. So I could say that 4x plus 20 is a corresponding angle to this. Or 4x plus 20 is, no, this is the exterior angle. Let's go that way. Here's the exterior angle. Here are my two remote interior. So 45 plus 75 equals 4x plus 20. I could use this equation, combine like terms, and solve for x. And now I know what x equals, I know what y equals, and I've solved it. So you'll have problems that are as complicated as this. We'll practice some. But this is about as hard as it will get. So if you could figure out this, you're good.